Ellipse. The next conic which we're going to discuss here is ellipse. As we have seen that ellipse is the conic section of a cone when cut other than 90 degrees. As we have seen in the previous case that a cone which has the height and the radius is cut slantingly or sliced slantingly, we get an ellipse. That's how this is cut, and we get this conic section, which is an ellipse. So when this is cut other than 90 degrees to the height of the cone, we get slantingly the area of cross section, which is an ellipse. So the cross section gives us the conic section ellipse. So we're going to study in this topic about the various topics of ellipse or the properties. Now that we have discussed about the ellipse related to eccentricity, let's recap with the ellipse. The ellipse, which generally looks in the shape of egg-shaped structure, with this being x-axis and this being y-axis, we have the focus and the point P, which is given by SP. Now I have a directrix which is a fixed line for the fixed point S. This. Now we have the definition of ellipse, which is generated from the fixed point S and a fixed line L, which is called the directrix, and this which is called the focus. The fixed point S and the fixed line L generate the ellipse, provided that SP by PM, which is denoted with eccentricity E, is less than 1. That's how we define the ellipse. If SP by PM is less than 1, we call this as an ellipse, where S is the fixed point and this is the fixed line, the directrix L. So SP by PM is less than 1, or SP less than PM equal to E is how we define the ellipse. Now let's see equation of ellipse in standard form. So as we have equation of ellipse in standard form, which we're going to discuss here. Now we know that an ellipse is generally an oval shaped structure in this form, which is exactly symmetric about x-axis and y-axis. This is exactly in the center, where this is origin and this is the focus and this is the point on the ellipse, and this is the directrix L, and this is joined by SP and PM, and this is the point of intersection of the axis and the directrix. So Z is foot of perpendicular from focus to the directrix, and this is the vertex of the parabola of the ellipse, or this is where the center of ellipse, and I have A dash, and this is B dash. Now corresponding to this focus, I have a focus on the left which is S dash, which is image or reflection of S with respect to y axis. Now this is the directrix L dash with respect to point P dash connected with PM dash, and this is Z dash. Is how we define the ellipse with all its properties. This is how we get the whole of ellipse with each of them defined in this way. So here S and S dash are called foci of the ellipse. The plural of focus is foci, and then are called directrix, and then I have S dash and L dash and C, which is center of ellipse, is how I understand each of the structures or the properties of the ellipse in standard form. Now, what is the equation of ellipse in standard form is what we're going to discuss in the session continued. Now let's see what are the coordinates of each of C, S, S dash, Z, Z dash, A dash, B dash, etc. So we'll see each of the coordinates and then define the equation of standard form of ellipse. So we know that the center is in the origin, so the coordinates of C are 0, 0, and the focus on the right is given by the coordinates AE, 0. And the coordinates of S dash are minus AE, 0, because it is exactly on the left, and this distance equals this. On the negative side, this will be minus AE, 0. And the coordinates of A are A0, and the coordinates of A dash are minus A0. And the coordinates of B are 0B, and the coordinates of B dash is 0 minus B, because it's on the down. So this makes me understand that CA is A and CA dash is also A, that is negative side of A, and CB is B and CB dash also is B, as I can see. So this is A and this is A, so AA dash will be 2A. And BB dash will be 2B, as we can see here. Now clearly I see that this is greater than this because this is flattened and this is bulged. So AA dash, in this case, the condition is that AA dash is greater than BB dash. That implies 2A is greater than 2B. That implies A must be greater than B. So for this kind of an ellipse, A must be greater than B is how we understand. So A is greater than B, as can be clearly seen in the diagram, where this is larger than this distance out here. So A greater than B for this ellipse. The focus, the center, and A is given, and the coordinates of the foot of perpendicular from focus to the directrix, which is Z. Z is the foot of perpendicular from focus to the directrix, and Z dash is the foot of perpendicular from focus S dash to the directrix L dash is what we see here. So the coordinates of Z are given to be a by e comma 0, and the coordinates of Z dash are given to be minus a by e comma 0. And we know that equation of this axis is y equal to 0, and the equation of this axis is x equal to 0. Now this is called major axis because it has the major segment of the ellipse, and this is called the minor axis because this has the minor segment of the ellipse. So this is the major axis, and this is the minor axis because this has the major segment along x-axis and minor segment along y-axis. Now with this, we are going to define the whole of the equation of ellipse in standard form. Now also, as I see that the coordinates of z is a by e comma 0 and this line is parallel to y-axis, therefore equation of directrix is given to be, as can be seen here, the coordinates of z are a by e comma 0, then the equation of directrix is given by the line which is parallel to y-axis. Therefore, this line being parallel to y-axis has its equation in the form with x equal to 0. This will be x equals a by e. And here the equation of L dash with x coordinate being minus a by e will have x equals minus a by e are the two equations of directrices as we have here with L and L dash. Now with the condition that a is greater than b and both a and b are greater than 0, and for eccentricity e which lies between 0 and 1 because e is less than 1 for ellipse and e is obviously greater than 0, so e lies between 0 and 1. So therefore, with the condition that a is greater than b and this is this and this is this, the equation of ellipse in standard form is given by with b square equals is what we get as the condition. The condition b square equals a square into 1 minus e square is the condition for standard form of ellipse. Now let's see the case where a is less than b. In the previous case, a is greater than b, so the ellipse was having its major axis along x-axis. So for a less than b, for ab greater than 0 and 0 less than e less than 1, let's take the case 1 of a less than b. So for the case of a less than b, I have the ellipse which is in the shape inverted out here. In the previous case, it was in this shape and now it turns onto y-axis. The major axis turns onto y-axis and the minor axis turns onto x-axis is how we see the difference between a greater than b and a less than b. Now the center of ellipse is this, which is 0 comma 0, and this is a dash and b dash. My focus shifts here and my s dash also is here, and then we have the directrix. So in this case of x-axis and y-axis along which I have the ellipse with a less than b, then my focus here is 0 comma BE and 0 comma minus BE is what we get as the focus, and A is A comma 0 minus A0 and B is 0B and 0 minus B, and coordinates of Z is 0 comma B by E and Z dash is 0 minus B by E, and equation of directrix is y equals B by E and y equals minus B by E. Equation of minor axis is y equal to 0 and equation of major axis is x equals 0 is how we get each of the properties which we have identified in the previous case. The only difference being that the major axis shifts to y-axis and minor axis shifts to x-axis as in the previous case. And equation of ellipse is given by x squared by a squared plus y squared by b squared equal to 1. A squared equals b squared of 1 minus a squared. Now we clearly see that the whole of ellipse in the previous case is shifted to this, then for a greater than b shifted to a less than b, all b squares are replaced with minus b square, and therefore I get the condition a square equals b square times 1 minus e squared for this ellipse. And we have the length of major axis or the length of minor axis in case of this being AA dash and BB dash, which is 2B, and AA dash, which is 2A. The equation of ellipse in standard form is given as x squared by a squared plus y squared by b squared equal to 1 for a greater than b. And for this, we know that the eccentricity lies between 0 and 1 for the ellipse. Let's see what is the value of eccentricity. Now for this ellipse, we know that b squared is a squared times 1 minus e squared, and for this we have b squared is a squared minus a squared e squared when expanded through the brackets. Now we want to make e the subject, so I take all e terms to the left, and therefore I get a squared e squared is a squared minus b squared. That implies e squared is a squared minus b squared by a squared. This on simplification gives but I do not take the plus minus value because since e lies between 0 and 1, therefore e is plus of root of a square minus b square by a square is what we get as eccentricity of the ellipse, or this can also be taken as root of a square minus b square by a is what we get as eccentricity of the ellipse. Now for the equation of ellipse in standard form, where I have case 2 with a less than b, then let's see how we get the eccentricity formula. So in case of a less than b, we have a squared equals b squared times 1 minus e squared as the formula. That implies this on simplification gives a squared as b squared minus b squared a squared which on simplification gives b square a square is b square minus a square. This as this, but I take only the minus value since 0 less than e less than 1. Therefore, e is root of b square minus a square by b square, or e is root of b square minus a square by b. This is how I get the eccentricity formula connected with the equation of ellipse, with a less than b as case 2 of the formula. Now let's see the length of major axis and minor axis. As we have two cases here of the ellipse, which is in this form, and here the ellipse, which is in this form, we see that these two are the cases here with a greater than b, and this with a less than b. So with these two cases of a less than b, a greater than b and a less than b, we have two types of ellipses, one in this form and one in this form. So here, as we have seen clearly, that this is a dash and b dash, and similarly out here. Now here the major axis is x-axis, as we all know, because it makes the major segment of the ellipse, and here this is the minor axis, since this makes the minor segment of the ellipse. But as you see in this case, this makes the major segment, so major axis is along y-axis. Therefore, in case of a less than b, the y-axis acts as the major axis and this acts as the minor axis. So in this case of major axis, we have length of major axis, which is given by the length of a dash, that is nothing but 2a, and this is 2b. It's 2a, and length of minor axis is bb dash, which is 2b, is what we get as major axis and minor axis. But as I see here, my major axis is bb dash, so my major axis is 2b and my minor axis as 2a. Clearly I can see my length of major axis is bb dash, which is 2b, and my length of minor axis, which is a dash, is 2a. Is how the whole of the concepts change with the a greater than b and a less than b. So length of major axis is 2a and length of minor axis is 2b, but in this case length of major axis is 2b and length of minor axis is 2a, because a is less than b and a is greater than b. And here the major axis is along x-axis and minor axis along y-axis, but in case of a less than b, the minor axis is along x-axis and major axis along y-axis. Now let's see the equation of ellipse with center as hk, that is, the center is non-origin. So in this case, clearly I see that the center, which is origin, is transformed to this. So let's take the transformed equation of the original standard of ellipse. So in order to do that, we always need to understand the standard form of ellipse as compared with the transformed equation of ellipse. Say for example, I have for a greater than b, if suppose my equation of ellipse in the standard form is x squared by a squared plus y squared by b squared equal to 1. Equation of this kind of ellipse is given by this, and this here, the center is origin and the focus is a comma 0 and s dash is minus a comma 0 and my a is a0 and my a dash is minus a0, b is 0b and my b dash is 0 minus b, and my directrix, which gives z as minus a by e comma 0 with z dash, and here my z is a by e comma 0, and the equation of directrix is x equals minus a by e, and this is x equals a by e. Is how we get each of the contents of this kind of an ellipse. Now let's compare this with the transformed equation. If the center origin is transformed to say the new equation, that is hk, then this center transformed to hk makes us understand that equation of the transformed equation is x minus h whole square by a square equal to 1. So this is the equation of transformed equation of ellipse, where I have my capital X as x minus h and my capital Y as y minus k. So each of the coordinates, the new coordinates of this standard form of ellipse, is obtained when I replace the x with x coordinate and y with y coordinate. Say for example, I want to find the new center for this ellipse, then my x coordinate of the original center is replaced with x equal to 0 and y equal to 0, because x coordinate is 0 and y coordinate is 0. So to find center, I have a greater than b, and to find center I just take x equal to 0 and y equal to 0, and therefore I get capital X, which is x minus h, equals 0 and y minus k equals 0. That implies x is h and y is k. Therefore with x equal to h and y equal to k, I get my center as hk. That is, the new center for the transformed equation of this is hk. Is how we find each of the contents, with center being hk for this equation. Now let's find the focus S for the new transformed equation using the standard form of the ellipse. The focus S AE comma 0 when transformed is obtained by taking x equal to AE and y equal to 0, where my x is x minus h equals AE and my y minus k is 0. Therefore I get my new coordinates as x equals AE plus h and y equal to k. Therefore the focus the new transformed focus is AE plus H comma K. Similarly, my S dash will be minus AE plus H comma K is what I get for the new coordinates of the transformed equation of ellipse. Now next, to find the directrices L and L dash. So to find the directress L and L dash, I have my equation of directrices x equal to A by E, that is x equals A by E and x equals minus A by E. Therefore, the new directrices would be, by taking x minus h is A by E, therefore equations of directrices is x equals h plus or minus A by E is what we get as the new directrices for the transformed equations, x equals h plus or minus A by E. Similarly, if I want to find the equation of major axis, in case of the standard form, equation of major axis is y equal to 0 and equation of minor axis is x equals 0. So in order to obtain the equation of major axis, I clearly see this to be along x-axis where y is 0, therefore the capital Y equal to 0. That implies y minus k equal to 0, and that implies y equal to k. So the major axis is a line which is parallel to y-axis, x-axis, and a distance of k units from here. So this will be k units from the x-axis and parallel to x-axis. So y equal to k is the equation of major axis for the new transformed equation. X minus h whole square by a square plus y minus k whole square by b square equal to 1. Similarly, equation of minor axis, which is x equal to 0, is with capital X equal to 0. That implies y equals x minus h equal to 0. That implies x equal to h is the equation of minor axis, which is a line which is parallel to y-axis and a distance of h units from y-axis, is how we understand the equation of minor axis for the transformed equation of ellipse. Therefore, for the ellipse, x minus h whole square by a square plus y minus k whole square by b square equal to 1. For a greater than b, we have b square equals a square into 1 minus e square, which doesn't change for any transformed equation. This is fixed. And for this, the length of major axis and minor axis are also fixed, where the transformed equation has the shape with directrix L and L dash, and this is the center, this is the foci AA dash, Z dash, BB dash, and how we get each of. So here the center of the transformed equation is HK. The focus is h plus a comma 0, and s dash is h minus a comma 0, and this will be a0, which changes to x minus h. So h plus a comma k, and h minus a comma k is what we get. Now here b is 0b, therefore 0 in the sense it comes as h, and b, which is y minus k equals to b, gives us k plus b. And here this is h and k minus b for b and b dash, and s dash. Now my z is a by e comma 0, so x minus h is a by e, so h plus a by e comma k, and h minus a by e comma k is what I get for z dash. An equation of the directrix, which is x equal to a by e, is x equals h plus a by e, which is the x coordinate of z, and this is x equals h minus a by e, which is the x coordinate of this, is how we get the center, the foci, the directrices, and the endpoints of major and minor axis. Is how we get as the transformed equation of ellipse for the standard form x squared by a squared plus y squared by b squared equal to 1 with a greater than b. Now let's take the case of a less than b. So in this case, case 2 of a less than b, I have my ellipse which goes like this, Now in this case of an ellipse where I have the center as origin and my focus S and S dash, which are given by 0, B and 0 minus B, and this being A, which is A0, and A dash, which is minus A0, and B, which is given by 0B, and B dash, which is 0 minus B. I have the directrix which are given by the equation y equals b by e and y equals minus b by e, so that my z is 0 b by e and my z dash is 0 minus b by e. So using this, let's see what will be the transformed equation of this ellipse x squared by a squared plus y squared by b squared equal to 1 with a less than b. So in this case of transformed equation, I get the new transformed equation of ellipse with center being hk, and for the ellipse x minus h whole square by a square plus y minus k whole square by b square equal to 1 with a less than b. So let's see what will be each of the focus, the directrix, etc. Now as I have this 0b, my x minus h equal to 0 reduces to this, and y minus k is k plus be, and this would be h and k minus be, which I get for the focus. And then this is a and a dash, which gets transformed to a plus h and k, and h minus a comma k, and this would be b and b dash, as I see here 0b, so x minus h, which gives h, y minus k, which would give k plus b, and this would be h k minus b. And the directrix which is given by y equal to b by e implies y minus k, that is y equals k plus b by e, and y minus k equal to this implies y is k minus b by e. This is how I see each of the properties getting transformed from this standard form to the transformed equation of ellipse. Similarly, my z, which is given by the coordinate 0, which is h, and k plus b by e, and here my z dash, which is h and k minus b by e, is strictly obtained from here. But length of major axis is 2b and length of minor axis is 2a, which remains the same. So equation of ellipse in the transformed form is given by this. This is how we understand the ellipse formulae using the standard form of ellipse.